This is a production of Cornell University.
Okay, thanks. Yeah, Louis Longchamps, Assistant Professor of Digital Ag. My position is 50-50 research and extension. Yeah, and I started in 2020. So my program, what I'm trying to do is to try to address the important change that needs to happen from more like an extraction mindset to a more sustainable mindset in agriculture. And this really requires a lot of change. And it's important to remember that change is a people's process, because we may invent lots of different solutions, but in the end, it will be a farmer, it will be a user that will implement that change or not. And it is quite a process, actually. So a recent study published by Ruiz et al. 2024, they show that it's kind of this long process from inaction to the full integration in the operations of the farm. You can divide this process into two sections. Okay? So the first part is perception, that goes from negative perception to a positive perception. And this is where I've been operating over the last 20 years, writing publications, extension bulletins, information that will kind of try to bring the farmers to perceive it as positive so that they want to implement it on their farm. And then there's another part, which is the action part. And in this part, farmers are experimenting with that new approach, new tool, new machine. They want to see if it really works for them. Okay, and just a quick parenthesis here. This process has been going since the dawn of agriculture. That's how we've evolved to where we are today. Farmers, they will try something in a little bit. They won't risk to the food for the entire tribe, the entire village, for the entire farm. They will try it, and if it works, then they will expand to the rest of the farm. So this is not a new process, but it's a process that doesn't get the attraction of scientists much. Yet it is super important, okay? Because in this, what's happening there is that farmers will experiment with something. And if they find that it doesn't work on their farm, then we are back to square one, because now they gathered evidence that it doesn't work. So now they go back to the resistance, you see? So they have the proof that it doesn't work. But then after that, bringing them back to positive and experimentation is quite cumbersome, because in a normal process, what Ruiz et al. Found is that this was a study over 6 years with 50 farmers experimenting with cover crops. They found that going from one box to the other is about 2 years, okay? So if you go back by 3 boxes, there you go. I mean, you just slowed the process quite a bit of change, actually. So that's it. That's what I'm trying to do. Operate at this stage, okay, where farmers are kind of left to themselves to experiment. But we all know conducting an experiment, putting the things in place, gathering the data, interpreting the data, that's not so simple. And for them, it's really a system that is prone to error. So what I want to do is to build a program for farmer-led on-farm experimentation enhanced by digital agronomy. So what does that mean? So this process, we need to collect and organize data. Then we need to experiment and interpret to learn. And then we want to proceed to evidence-based change. So if we change sometime and it's not based on scientific evidence, it could backlash, and then you need to backtrack. So to do this, everything is to be, I mean, there's a lot of things to be done to make this system work, okay? So we are working on a project here where we can use a voice-based system in the tractor to collect the data, what was done, when was it done, so all the operation, the crop management. Then one of my students is working on a web-based tool where the farmer could just highlight where the experiment took place, and then a bunch of layers to contextualize that experimentation is automatically gathered. We can think of weather, remote sensing data, topography, sea drought stress, and things like that. Then after that, it's a matter of finding ways to really work with farmers, okay? So I've been doing this project over the last 2 years, and you see farmers, they don't experiment like us. They would do like a side-by-side. Sometimes it's like a different field, or sometimes it's just a strip, but it's a matter of finding how we can support that process and not really trying to change it, because we can convince them to do a fully replicated, but now we're working with 2% of the farmers. Okay, and then after that, in a workshop, we put the data together and then we interpret it together. So it's a process where we don't arrive with answers and solutions, we just build it together. And the thing is that when you do this, the learning happens throughout the experimentation. So at the end, they are able to use it on their farm. And then there's another layer that we can work on is to, when we are able to integrate all the data together, now we can see trends and patterns that happen at the network level that kind of can lead to more generalized knowledge for the field of agronomy in the field crops, I mean, in my case. And then after that, it's just a matter of documenting, finding ways to make a virtuous cycle where we have digital ag, social science, agronomy working together to make a system that is very efficient and that you can build from year to year into something that will accelerate or improve the way we farm. Okay, in the grand scheme of things, this is the vision that I have. Okay, farmers are experimenting to get pragmatic knowledge. It works, I'm not sure why. And then in academic, we are looking for semantic knowledge. I can quantify this, I'm not too sure if it's useful or how it could be used. So both of these can really work together to create a dynamic to accelerate the knowledge creation, okay? And how it works is that on the on-farm experimental side, you have observational research where we use big data and AI to find trends and patterns. But here, we cannot really explain why, but we can detect them very strongly because we are working with big data. On the other side, though, you have experimental research that use experimental design and stats, and then we can find causality and quantify the relationships. So the idea is that we come to a system where on-farm experimentation generates hypotheses, okay, because we see things that we don't understand. And then academic research provides understanding. And this way we can grow faster and yet understand what the heck we're doing. All right, thank you. Questions? Yes.
Does anybody else have a question? I love this approach a lot, and I'm wondering if you have experienced any pushback from farmers about sharing the data. I found that to be this limiting step. The logic of it's there, but there's some sense of privacy that seemed to obstruct that. Did you encounter that?
Yes, I mean, we see this a lot, but what I see on the field is I hear this sentence, the more people looking at my data, the better. Because you need to remember that these are farmers that experiment something. They are trying, they would do it if you're there or if you're not there, okay? So they really want, that process is important for them and they want to learn from it. So farmers, they share things like, the more people looking at my data, the more chances I get something out of it. There's one piece of data that is super hard and I actually cannot trust is how much manure was applied. Yep. Yep, this one is a tricky one. They don't do anything but that one.
Why is that?
I mean, the thing is that with the KFO, you have a certain amount that you can apply.
Yeah.
But every truck load, you need to pay for the fuel. So if you're, yeah, you may not end up where it was supposed to end up. And then, yeah, that's a tricky one. Yeah.
This has been a production of Cornell University, on the web at cornell.edu.